Welcome, everyone. My name is Brittany Todd, and I'm a member of the Fabric leadership team. Thank you all for joining us today for the fifth installment in our Mastering Fabric Tips and Tricks webinar series, led by Tom Lehman and a demo by Ben Formby. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live Q&A session, question and answer session, following the presentation. Please note that the chat feature has been disabled, but if at any point you have questions, please type them into the Q&A box at the bottom of your screen, and we'll answer it during the Q&A session. Last, this webinar is being recorded and will be shared with all registrants. Next slide, please. We are joined today by our presenters, Tom Lehman and Ben Formby. Tom Lehman is a member of the Fabric leadership team, working on the data plane network topology, network services, and experiment design. His research interest includes technologies and systems, which facilitates the orchestration of high-performance network, computation, and storage resources in the service of big data-driven domain science application workflows. Ben Formby is a PhD student at Clemson University with a research focus in AI and machine learning for medical imaging. He uses Fabric to create end-to-end experiments, implementing his AI applications in realistic network simulations. He has also been a part of the Fabric Students Group for 2 years now, assisting with user support for the testbed. I will now pass to Tom to start the presentation.
Hello, everybody. Thank you for joining. I'm going to talk today about Fabric facility ports and both the availability of them and also some of the use cases. And then Ben will be presenting a demo of an actual instantiation of a facility port and associated resources on Fabric. So I think a good place to start when we talk about facility ports is to first think about the overall Fabric topology, because when we talk about facility ports, we're really just talking about extending the internal Fabric topology to other resources. So if we look at the Fabric topology as I show on the map here, you can see that it's pretty extensive. It has quite a large footprint, and most of the sites are in the United States, but there are some international locations at CERN, and University of Amsterdam, University of Bristol, and University of Tokyo. And this allows us to do a large variety of types of applications and topologies and tying into a lot of different resources. You can see the orange line there, which is thicker than the rest, is shown as our terabit core. So what that means is that is a 1.2 terabit per second ring that goes around the footprint, both the northern side of the ring and the southern side. And that has a bunch of other connections, which you see in blue there. The blue ones are generally dedicated optical links, so very high performance, very deterministic behavior. The ones that are green are generally engineered links across other people's infrastructure, so those will typically have shared traffic. So when people are designing experiments, they might want to be aware of the type of links and the topology they're building, because you can do different levels of control in terms of the performance and the capability depending on which parts of the topology that you use. So if we think about in terms of the actual nodes which are on Fabric, one of the main premises of the Fabric topology is that it's not a regular network. Well, if we go back to this diagram, it kind of looks like a regular network from this perspective, but in reality, at every node is a little mini data center. It has compute, storage, it has the networking and programmable networking as well. So it's a little OpenStack cluster effectively. So every site allows you to do in-network processing that you would not typically be able to do on a regular network. And of course, this is because Fabric is designed for people to experiment using networks in ways which they cannot use networks now. So the internals of the Fabric network, the capability of the network, is important when we think about facility ports, because typically with facility ports, you're going to try to tie in some external resources which are not part of Fabric, but you want to tie them into the resources you have set up on Fabric. And as we see, as we go further into the talk here, it's very much what types of external resources you want to connect to, how you want to interact with them will be very determined and be related to what types of topologies you want to set up on Fabric, and there's a large variety. So So if we look at what types of resources are available at the Fabric nodes, you can see, as I mentioned, it's got compute, storage, and programmable networking. And when we talk about compute, we're really talking a wide variety there. There's CPU-based, obviously, and there's GPUs, there's FPGAs, there's, from a networking perspective, there's P4 switch capabilities, there's regular types of network services that are dynamically programmable in the infrastructure. And also there's storage, which is per slice or per instantiation, as well as some shared storage at the node. So you can really build a rich topology at every node. And then if you combine those across the entire network, you can really build complex and unique topologies which are embedded inside the network themselves. And you can see here just kind of an example of the types of resources, the types of GPUs and FPGAs. And so as we think about the facility ports, a lot of what we want to think about is what is being built inside of Fabric and how is it going to be connected to the facility ports. So keep that in mind as we go through all the services and the facility port options. So when we think about Fabric, there's multiple access points, and you can see here, this is kind of a diagram of what you see on a typical Fabric topology. This is just showing two sites. So on the left-hand side, Fabric Site 1 and Fabric Site 2, and you can see from the top, there's a management network, which allows you or the experimenter to get access to the resources. So typically on Fabric, you'll go in and you'll reserve a node, which will be in the form of a virtual machine, and you can decide what types of network interfaces you want to attach to that node. So you can attach dedicated smart NICs, you can attach shared NICs, you can attach FPGAs, which have network interfaces on them. You can attach GPUs if you need to do some GPU-based computation. And then they all attach to a data plane. So if you see at the bottom, the key thing there to note is that the experiments that people run, the data that they transfer from site to site is going across the data plane. The top network is really just for access and some operations types of activities. But we're really focusing on the data plane. So you can see when we talk about facility ports, the main thing we're talking about is, in addition to all the things you can do on Fabric, the way you can pull up resources at one of the 33 nodes and how you connect them together across the Fabric network. There's a lot of options there, but then you can also, as shown from the green connections to external resources, there are select locations in Fabric from the data plane where external resources have been connected. And those are there, and they are available for people who are building slices on Fabric to connect those external resources. And how you connect them and why you connect them and what they get connected to will be very much determined by the objectives of the experiment. And so today we'll talk about what those options are. And then for people who are designing experiments, you'll have to do something specific to the experiment and the objectives that you're trying to accomplish with your Fabric topology. So if we just think about, okay, what is a Fabric facility port? It's really just a connection to the Fabric data plane, which is facing an external resource. So an external resource is something that Fabric does not control. So everything on Fabric that we just showed in the Fabric topology, all the resources at the nodes, all the networking in between it, all the networking services that you can use to connect things at the different parts of the Fabric topology, those are all under the control of the Fabric control framework. So there's an API, there's a web-based GUI, there's a whole bunch of ways you can provision as resources, and the Fabric control plane knows everything about them and can respond to user requests, provide user information, keep track of the health of the slice and those kind of things. But when we talk about a facility port facing an external resource, now we're facing something that we don't control, say a Chameleon cluster or a Cloud Lab cluster or an HPC center. So now there's a little bit of a different problem to solve, is how do you coordinate the provision of resources on an external resource with the provision of the resources that have been done in a slice or experiment or specific way. So that's what we'll talk about today, is how you really put in practice these facility ports to integrate them into the Fabric experiment. So we'll just talk about some examples here, and then we'll go into some more of the details. So if we look at some facility port examples, here are just some of them. There's quite a few, and what we find is that sometimes Fabric facility ports are facing large resources which have large user bases, and they're expected to be used by many people. Sometimes people create facility ports which are really just for a very small group of people. And the way facility ports work is that on Fabric, they get established, and there's always an owner who's responsible for that facility port. So Fabric itself, the Fabric project, does not really decide who can use facility ports. Fabric just facilitates getting the facility ports in place. And then the user or the owner of that facility port is the one who decides who can use it. So, and the policy may be different for a very large facility like Chameleon, which we'll see a demo from Ben a little later in this presentation. There's an entire infrastructure for people to get user accounts for Chameleon. So generally the policy there is if you have a Chameleon user account, you can use the Chameleon facility port. So, but it'll differ facility port by facility port. But just to give some examples about why people might want to interact with the facility port, I'll just go through a couple of examples on the list here. So I'll just, at the top, you can see we have something called AmLite Express, and we have a layer 2 and a layer 3 facility port. So if I look back at this topology, you can see we have a Fabric node at Florida International University AMPATH, and there's an entire network, which is referred to as AmLite Express, that's run by the FIU AmLite AMPATH team, which has really rich connectivity into South America, Brazil and Chile, to a lot of scientific resources down there, both for weather climate modeling and for astronomy and other things. So as a Fabric user, if you have resources that you're interested in South America, which are connected by this RNE network, Fabric provides an excellent way to get access to those resources because there is these two facility ports that I mentioned here, AmLite. They basically will allow you to build a topology on Fabric, and you can have resources across the entirety of Fabric. You can include in that the facility port FIU facing the AmLite Express infrastructure, and then you'll have very high-speed, dedicated, research connectivity to resources that may be needed for your experimentation or your research. And in this manner, you can see the reason we have two different types of networking connections, and kind of this is for, at the networking detail level, but basically when it says layer 2 or layer 3, what that means is that you can get connected to the resources that are available through the AmLite Express network research infrastructure through layer 3 routing, which is provided through that facility port into layer 3 routed infrastructure that AmLite runs, or you can get layer 2 paths. So it's a rich way of getting connectivity to those types of resources. Just as another example, there's a Starlight, which is referred to as 3x400 at Star. So what that means is that there's a Fabric node up here at Starlight, and facing all the resources at Starlight. Starlight has a lot of resources, a major exchange point with a lot of international connections in downtown Chicago. And there's a lot of research infrastructure there. There are a lot of universities, they co-locate equipment there. So from this facility port, you can get 3x400, so basically a 1.2 terabit per second connectivity is available into resources that others may have at Starlight. So if you have collaborators which have resources at Starlight or which are connected through Starlight, this is a way that you can then, again, using that facility port, you can tie in resources from anything that's at Starlight to the experiment slice that you may build on Fabric. Let's see, just a couple other interesting ones. Ultrasound Clemson. So that's a experiment at Clemson, and Ben will talk a little bit about that. But basically, there's an instrument there that you can use, and you can use a facility port from the Clemson node. You can see the Clemson node here, kind of the right-hand side, and that would be a way to get connection to that. The Rutgers cryo electronic microscopy. That microscope is at Rutgers, and there's going to be a separate use case, facility port use case webinar on that tomorrow. But just to talk quickly about that, that's at Rutgers, so that's also available via facility port. NSF access, I mentioned that. That's the NSF HPC access facility, and that's a little bit non-standard facility port. What that is basically just means that there are external connections in the form of facility ports to the NSF access facility. So if you're on access and you're running resources and you have resources on Fabric, you'll have direct connectivity between your access resources and Fabric resources through that connectivity. If we look back at like Chameleon and Cloud Lab, those are some of the larger facilities, and you can see also in the orange text here, you can see where we have different things connected, and those are facility ports. So you can see that we have Chameleon resources at multiple locations, and Starlight and TAC are the main ones. And that basically allows you from a Fabric node at either TAC, which is the Texas Supercomputing Center, or at Starlight, you can have a facility port facing the Chameleon resources, and that'll allow you to integrate things you're doing on Chameleon as well as things you're doing on Fabric, and that will be the subject of Ben's demo as later in this presentation. And Cloud Lab is also similar, where there's Cloud Lab resources at University of Wisconsin-Madison, at University of Utah, and also at Clemson. And that's another example where you can use the Fabric facility ports to integrate resources on Cloud Lab and also the Fabric slice that you may set up. And there's also wireless test beds, Powder, and Cosmos. So the message here is that there's a lot of different facility ports. How people may want to use them is going to be very experiment dependent. And we can always add facility ports, and I'll talk about that process. So if you know people that have external resources that you think would be beneficial to have attached to Fabric, then you can contact the Fabric team, and we can look at it and see if it's technically possible and then what it would take to do that. The last one I'll mention is that the Internet 2 Insight portal, they have a lot of services that Internet 2 provides, and one of them is public cloud access. So they call it the Cloud Connect service. So Fabric has facility ports facing Internet 2 and facing those services. So if you're building something on Fabric and you want to include access to public clouds, there's also a way to do that through dedicated peerings to Internet 2. So you can do a nice slice on Fabric and have whatever embedded networking types of processing you may have on Fabric, and you can integrate that into public clouds in a standard and automated way. So just quickly, what does it mean? How do we actually get a Fabric facility port connected? And so it's really quite simple at the infrastructure level. It's really just a matter of getting a connection. And the best way is if we have a site where there's a Fabric node and the external resource is there, and we can run a fiber, across the campus or across the facility. That's the best way, and that's what we always try to do. And that's kind of the top scenario, is that we try to find out for the locations where we have a Fabric rack already, what are the external resources there that are interesting to make available in the form of a facility port. If we have an external resource and there's not a Fabric node close by, we can still do a remote networking provisioning. We can do a circuit across the ESNet Oscars or Internet 2's AL2S, and we can connect in resources that way. Logically and functionally, it looks very similar. It's just not quite a high quality of connection as having a dedicated fiber across a resource, but both of those are possible. But the thing to note about this is once we've done this, this is like the infrastructure level connection. It really hasn't provided any connectivity between the external resource and an experiment slice or an experiment resource. So in order to make it useful, once the things are connected at the infrastructure level, then you have to think about what is the experiment, what's the research, what's the slice that somebody wants to set up, and then how do you want to connect it to the external resource? Because on Fabric, there's a rich set of network services about how you connect resources within Fabric, and then how you can add network connections to the external resources. So all the network services that are available for intra-Fabric are also available for connecting to external resources. So it's useful to just look at those network services for a little bit so people can get an understanding of when you think about bringing in an external resource through a facility port to your experiment slice on Fabric, how do you want to connect it and what are your options? So at kind of an overview level, these are the types of ways from a network service perspective you can glue things together on Fabric into external resources. And I'm just going to go through these quickly just so you can see what those are. But basically, the most basic case is just an L2 bridge where you could have multiple resources on a single Fabric rack and just connect them in a layer 2 manner. So this is just a standard, Ethernet VLAN that you may connect. What I'm showing here, though, is that kind of within the Fabric site box, you see 2 VMs, which are pulled up of the Fabric resources. They're connected together with an L2 bridge, so you could have multiple NIC cards on the VMs, and they're connected together. But there may also be, if there's a facility port at that site, you can also bridge in the external resource through a facility port. So then what you would have is you would have that external resource directly connected to your resources on Fabric at that site, just with a standard layer 2 shared broadcast domain type of connection. In addition, we can do things across from Fabric site to site, and there's a couple of ways to go site to site. There's layer 2 and layer 3 ways, but one of the ways is what's known as a layer 2 point-to-point. And what's interesting about this is a dedicated connection, layer 2, between 2 Fabric sites, resources at 2 Fabric sites, and it can go anywhere on Fabric. And it allows you to do things for people who want to do very deterministic and performance guaranteed types of things. This service allows you to set up connections between 2 points on Fabric and control the routes. And also, we're soon going to have the quality of service features available for that as well. So you can think about this as if you have an experiment which needs very deterministic and repeatable types of operations, this is a good service to use as kind of the foundation of your underlying Fabric experiment. And you can use that same service if there's a facility port facing an external resource, either at the site on Fabric where you're using most of the resources or at any other site on Fabric. You can do a layer 2 point-to-point to glue in that external resource, within one site or across multiple sites. So if you have a need to get to an external resource and it's a Fabric facility port that is facing that, then you can do a layer 2 point-to-point. And if you're really interested in guaranteed quality service and controlling your routes, this is a good way to do it. So when we say controlling your routes, you can see that Fabric has that large topology. So if you're going to do a point-to-point between two sites on Fabric or between a site on Fabric and a facility and an external resource via facility port, you can control the route. So maybe you want to have a very long route, or maybe you want to have a very short route, or maybe you would like to go across Fabric for a while, hop off on another facility port, maybe get to another resource like Chameleon or Cloud Lab or National Research Platform because there's some particular computation resources or other scientific resources you want. Then you can hop back on Fabric and you can continue another route. So the message here is that with this point-to-point service, you can control the routes, you can control the quality of service once we have that rolled out, probably in January. And then you can really control very detailed and interesting topologies, which you can then repeat and set up later. And if you don't care about those things, you can just kind of let the network take whatever path it wants. So you don't have to use these advanced features. The other one I mentioned is a layer 2 site-to-site service. So what that does is that just allows you that instead of kind of having a single connection at the ends of the layer 2 circuit, you can have multiple connections. And this is a little more flexible because you don't have to, you're not quite as limited to how many resources you can have at the other end, but you don't get as many deterministic features. So it's kind of a trade-off between, are you just trying to build a layer 2 infrastructure across multiple sites and external resources, or do you really want to control at a fine-grained level the quality of service and the path? So that's just an option to consider based on what your objectives are for the experiment. And there's also layer 3 services. So if you don't care about any of that layer 2 connectivity, you just want basic layer 3 service, which will be a shared type of data transmission. You can basically get V4 or V6 networks from Fabric, and you can route to everything. So if you have a facility port somewhere on Fabric facing some external resource, you can configure that facility port. You don't even need to pull up a VM or anything. You just simply attach a network service, and you can basically get some Fabric IP space, and you can make it available to your external resource. So now you can go into your external resource, you can set up whatever resources you want, and you can route into Fabric, and you can route into anything else you have on Fabric. So this is a layer 3 service, which just makes it easier to get connectivity between your external resource and the resources on Fabric. But you don't get this fine-grained control that you made with the layer 2 service. So again, it just depends on the objectives of the experiment. In addition, for the layer 3 service, the routed service, we do provide on Fabric a way to get not only routed within Fabric, but to get out to the external internet, both the R&E infrastructure like Internet 2 and ESNet and all the campuses and universities which are peering, in the R&E infrastructure, but also to the regular commodity public internet. So if you have a need to do that, you can do that. Fabric is a little bit more restrictive on who's allowed to do that because it's a little risky to just have open services sitting on the internet. So there's more of a review process. So technically it's easy. It just takes a little bit more of a review process. And there's a way for these things to be requested through the Fabric portal. You can just go in and ask for permission to do certain things. And getting a connection to an external IP routed service is one of those things. So in the end, when we talk about these facility ports, the message is that there's a large set of external facilities which are connected now to facility ports. The Cloud Lab, Chameleon, public clouds, HPC centers, wireless testbeds, the National Research Platform for people familiar with that, which is a large distributed Kubernetes cluster run from UCSD. So you can build very interesting topologies. You can connect in a very heterogeneous set of external resources if you like, or you can connect in just the one external resource you're interested in. And you can interact with that in a lot of different ways through the many different network services that are available. And again, on Fabric, you can use the network services that Fabric has to do either layer 2 or layer 3 services, or you can use layer 2 services and build your own routed infrastructure, which people do. They pull up VMs and they run something like FRR, and they connect multiple network interface cards, and they use layer 2 services to just build an infrastructure on Fabric, and they run their own routed infrastructure. So there's a lot of different ways you can connect the resources on Fabric as well as the external resources through facility ports. So when we talk about how do you do this? So you have all the things on Fabric you want to set up on your slice. You have the networking services, you have the compute, the storage, and the virtual machines you want to pull up at all the different sites, and you want to connect them in a specific way for your experiment slice. And now you tie in external resources through facility ports. So how do you synchronize all that provisioning? So there's really kind of three ways to do that. One, I would call it, the first one is manual, where basically you just go into Fabric and you set things up about, just through the Fabric API, and you set everything up on Fabric, and you do it the regular standard Fabric way. And then you go into your external resource, and maybe it's Chameleon or Cloud Lab, and you use whatever API or mechanisms that you normally would use to set that up. And then you just do that, and then you have to do a little synchronization. Like if you're doing a layer 2 service, and Ben will talk about this in more detail, you have to understand, for this facility port physical connection, if you're going to connect via VLAN, you have to make sure you coordinate what VLAN you're using and things like that. So I would call it the manual process, where you just kind of do things separately on Fabric, you do things separately on the other infrastructure that maybe you're probably familiar with using, and you just do that somewhat intelligently so it connects together. The other way, and this is, I think, the way Ben shows tool-based, where you can go through Jupyter Notebook, and you can do this all in kind of one integrated tool-based perspective. You can have a Jupyter Notebook, it can have both the Fabric API in there, it can have the external resource API in there, and you can just build a common notebook that makes everything look like it's just a common interface through a Jupyter Notebook, and just do all of that, and it looks very much like a single provisioning environment. You just have to do a little bit of work to set it up so that you can talk to both resources, both Fabric as well as the external resource. The other one is Fabric does have something called FabFed, and it basically is just like the middle one. It's kind of just like the tool base, but it has a little bit of automation, kind of like Terraform, that allows you to integrate provider APIs into a little bit more of a standard framework, but it kind of does the same type of thing. It just makes it a little bit easier to repeat. If you're going to be doing this a lot of times, you have a lot of different, external resources you're interacting with, you may want to look at that. It just kind of helps set that up in a little bit easier manner in terms of repeating it. So if there's information and help, here's a couple of pointers. There's a knowledge base, which has information on facility ports. There's documentations on the API and other types of ways to interact with the Fabric control framework. There's some information on the FabFed that I talked about. And generally, we use the forums to ask questions. So that's a good place to start. And then we can also set up dedicated meetings to talk about very specific details about a slice that someone may have in mind and help figure out the best way to interact with that. So now we're going to talk a couple of facility port examples, and I'm just going to go through two. And then Ben, for the last one there, which is the Chameleon Fabric Layer 2 service, Ben's going to give a demonstration on that. The first one is just the remote instrumentation collaboration at Cryo-EM. And as I mentioned, there's another webinar on that tomorrow, dedicated on that. I'll just talk briefly about that. And the other one is a slightly different way to use Chameleon from what Ben will be talking about. So if we look at the Cryo-EM remote instrument, this is at Rutgers, and there's an entire workflow to talk about detail, but I just want to, from a Fabric perspective, you can see there's a Fabric node at Rutgers, you can see down here on the bottom center. And that could be used as like an edge processing, getting information from the instrument at a very close location because it's in the same facility, the same campus, and do on-site edge computing. But if in addition, you can see, and I tried to represent that by the Fabric topology here in a smaller version, is that Rutgers is one of those universities that has very good connectivity to the rest of Fabric, has a dedicated 100 gig layer 1 connection from Rutgers through New York into Fabric, which actually lands on a node at New York, which is the Fabric terabit core at mainland, for those people familiar with that part of the topology. So from there, you can also distribute workloads across Fabric using high performance dedicated network connectivity. And that allows you to really build a rich set of services on Fabric that are highly distributed. Maybe they're distributed because you're trying to get to certain compute resources, or maybe they're distributed because there's other external resources or locations you're trying to get to. And then you can also have the ability to do on-site local edge type computing. So this will be talked in more detail as tomorrow's webinar. The Chameleon example, in addition to what Ben's going to talk about next, is which is layer 2. Chameleon also runs a layer 3 service using facility ports from Fabric. to make it very invisible for users. So for the users who just want basic connectivity, say between the Chameleon facility of Starlight and the Chameleon facility of TAC, and they want to go across Fabric instead of going across the regular internet or the regular R&E infrastructure, we have set up a facility port, which is basically just a facility port on Fabric Star, Fabric TAC, which faces Chameleon, and there's no VMs, there's no nodes, it's just a network service attached to the facility port. And then that allows the Chameleon team to have a service within their Chameleon API, which just simply allows the users to set up whatever resources on Chameleon they like. And they say, I'd like to use the Fabric, infrastructure to talk between the resources at the different distributed Chameleon sites. And then it'll just automatically will use the Fabric routed infrastructure to do that. So there's a lot of ways you can build these services on Fabric that integrate very seamlessly into the external resources. And this is an example of that. There's a couple of links there which go into more detail about how that's done, and both from an infrastructure perspective and also from a user perspective on Chameleon. So now I think I'm going to turn this over to Ben, and he's going to show a specific example about how you set up a Chameleon to Fabric facility port-based connection.
Yeah, thanks, Tom. That was a great presentation. I will share my screen now. And so as Tom mentioned, I'll be giving a demo on how to connect a Fabric slice to the Chameleon facility port through a layer 2 connection. So I'll be walking through a notebook today in a Jupyter environment, and it's kind of divided into 2 parts, with the first part being straight from a tutorial that Fabric provides on their Start Here page. So if you go to the latest Jupyter examples folder and then open the Start Here page, you scroll down to complex recipes. Right here under Chameleon facility ports, this L2 connection, this is the first part of the notebook that I'll be walking through today. Now, the second part is a more specific use case that my team at Clemson University, we have a simple experiment set up that is doing live streaming of medical ultrasound video and then doing real-time feedback with machine learning predictions. And so now I'll get started going through this notebook. So the first thing that I want to show, if we go here to this link, this is Chameleon's homepage. And so similar to Fabric, you're going to need an account and be a part of a project on Chameleon to be able to use their resources. And then also on Fabric side, you'll need to have the permissions on Fabric in your project to access the Chameleon facility port. So if you're a project manager, you need to fill out that form to request that access. And then if you're a student or a user in a project, you need to ask your project owner to do that. And so continuing, there's a few things that we first need to do on the Chameleon side with their website and interface. And then once we have that set up, we can continue through our notebook. And so the first thing is setting up your Chameleon CLI password. And so if you follow this link, there's directions here in Chameleon's documentation on how to set this up. And then next is the OpenStack RC file, which there's also another link on how to get this file and download it from Chameleon. And so next, using that OpenStack RC file, we need to import all those environment variables to our Fabric environment. And so you can input all those variables here, or an easier, simpler way is to use this Python module to just import all of those variables with this line of code. And so that's what I'll do here. And then next, we're importing all of our libraries. So we're importing the Chameleon API and the FabLib Fabrics API. And then we're going to set up all of our experiment variables for the Chameleon side and the Fabric side. And so 2 important things to note here are the Chameleon key name, which is the SSH key generated from Chameleon so that we can access our Chameleon servers. And then next is the Chameleon server reservation ID. So when you're doing an experiment on Chameleon, it would be helpful to plan ahead for your experiment because you need to first make a reservation on Chameleon so that you can access that from Fabric. And so to do that, we'll go back to Chameleon's homepage. I'm already logged in, but once you logged in, you'll choose the site that you're working with. I'm working with Chameleon at TAC. And so we'll go here. Now we will then go down to this reservations tab, go to leases, and then we'll go to this host calendar. And so the host calendar will show you all the resources that they have and in calendar format so that you can see when they're available and what's available. You can look at all the different node types they have. We'll say we're going to use a GPU, a P100 GPU. And you can see there's a few open right now, but a lot are taken. And so that's why it's good to make sure to plan ahead and have a time in that you plan on using that resource. And so once you figure that out, when you're going to use it, what you're going to use, we'll go back to leases. We'll hit create lease, and then we'll give our lease a name. We'll just say server. You can choose a start date and how long you need it. We'll go over to hosts, the host tab, and then we are going to want to reserve a excuse me, reserve a host. And this is where you choose what kind. And so I already have one up and running, and I have a P100 GPU, so I won't reserve this. But and then this next tab is where you could reserve a network, but this is done in the Fabric Jupyter Notebook later on, so I'll skip that. And so then once you create that lease, you can click on it. I have one that is already active called Ben Formby host. And so if you click here and look at the details of the lease, you'll find this reservation ID. And so this is what you need in the notebook. And so we'll copy this and paste it in here. And then that should be everything that you need to do on Chameleon's side. And everything else can be done from our Fabric Jupyter Notebook. And so I'll go ahead and run these two cells, setting all of our variables for our experiment. Here's a command that can list all the available facility ports on Fabric. I'll skip that for now, though. And then this cell is specific to the L2 connection. This is setting up a L3 subnet that we're using in our experiment. And so we create an allocation pool for the IPs on the Fabric side, and then the same on the Chameleon side. And then this is giving a specific IP for our Chameleon gateway. And so in this next cell is where I have briefly mentioned before about setting up the Chameleon network. We can do this from the Jupyter Notebook with Chameleon's API. And so this is creating the network, getting the network lease and the network reservation ID. I already have one, so I won't run this cell. And then after that, we are getting that network with the Chameleon network name and then getting the VLAN that's used for our connection. And so running that cell, we have this VLAN 3472. We then need to add a subnet and a router on Chameleon's side. And so this cell is using the Chameleon API to create a subnet and then add a router so that we can connect our Fabric network to our Chameleon network. And again, I already have those set up, so I won't run those cells. And then this is where we build the slice for our Fabric topology. So this is a really simple slice. We have a single node with a network, net1, that we are adding a facility port to with the VLAN that we got and the site that the facility port is for. We then submit And I already have a slice running, so we won't have to wait for that to reserve. I will just run this to query all of the resources of my slice. We can see the single node. I'll go ahead and use this SSH command to connect to our node. We'll open a terminal and paste that SSH here. So we're in our node. Here's the networks and the interfaces of our slice. And we will do a ping test, make sure we're connected to the Chameleon gateway. And that was successful. And so the next step is to start our Chameleon server. So we got the reservation. Now we are starting the server. And so this cell can take quite a while to run. It can take up to 20 or 30 minutes for the servers to start up. But I already have one up and running, so we won't need to wait. And next, we need to get the fixed IP for that Chameleon server. So that's what this cell does. And our Chameleon server is 192.168.100.119. And we can test the connection to that from our Fabric node. And we can successfully connect between our Fabric and Chameleon node. So that is the end of the first part of this demo. So everything up until now you can find in the tutorial on the Start Here page for an L2 connection to Chameleon with a facility port. So now I will go over a quick use case that is similar to some of the experiments that we're doing at Clemson with live ultrasound video streaming and then doing remote processing with a remote GPU on a node at Chameleon. And so this is the topology as shown in the slice viewer on the Fabric portal. This first node, node 1, represents our ultrasound system and streaming service at Clemson. This is our Fabric node, and then that is connected to the facility port, and then eventually to the Chameleon node. Yeah. And so then these next few cells are just setting up the stream service on our Fabric node. It's installing all the needed packages and starting the stream server. So I'll skip through those cells for now. And then next, we upload everything needed for the experiment. So I'm uploading everything to the Fabric node first, and then using SCP file transfer from the Fabric node to a Chameleon node to give the Chameleon node a script that makes some machine learning predictions on the incoming ultrasound video frames. Also send a PyTorch model that the Chameleon node uses, and then also send a setup script that installs everything needed on the Chameleon node. And then we give an ultrasound video to the Fabric node, which is then streamed on loop to the Chameleon node. And then we also need to upload our Chameleon key so that we can SCP and SSH. And so now, once all that's set up, which I already have done, we can run the experiment. And so we'll run this command on our Fabric node, which is an ffmpeg command that starts a stream. So I'll go ahead and run that. So it was already, the stream server was already streaming, and that's ready to go. And then now we can SSH to our Chameleon node, which I will copy this command. And we're now in our Chameleon node. And then I'll go into the uploads folder that I transferred from our Fabric node. And then we can run this script that makes predictions on the incoming video frames. So we'll copy and paste that and paste it here on the Chameleon node. And what this script is doing is it's reading in frame by frame the streamed video, and it's making, it's just running a simple PyTorch model and predicting whether frames are healthy or unhealthy. And so you can see the timestamps of every frame coming in, the processing time, and its prediction. And that concludes the demo. It's always good once you're done with your experiment to clean up. For the chameleon, you need to delete the server, and then you also need to tear down the network that we built and free all the leases, and then eventually delete the fabric splice. And so you can imagine an experiment like this, you can scale it up and also do a lot of interesting things with distributed learning, or apply it to a lot of other applications. And so now I think I will hand it back to Brittany.
Thank you both so much for this presentation. We are now going to move to the Q&A session, and we'll begin with any questions that were submitted during the presentation. So we can go ahead and stop sharing the screen at this point. And the first question that we have is, what are the options and best practices to create the infrastructure level connection to an external resource?
Yeah, okay, I think I can answer that. So, yeah, it really depends on the nature of the external resource and what the objectives are of the experiment. So what we find is that a lot of these external resources, people are very much interested in high performance and deterministic behavior. And in that situation, it's always best if there's a Fabric site very close to the resource. And so, we have a lot of Fabric nodes which are located at exchange points, and that provides opportunities to connect things which are maybe exactly at the exchange point, or sometimes even something in the region of an exchange point can be connected with a very high performance networking path. So that's always the best way, is to find a Fabric node which is exact same facility where the external resource is, or something close that has really good regional networking in between. In some situations, we will do longer distance connections, like we have done connections between a Fabric node and external resource which may be further away, and do like an Internet 2 AL2S type of layer 2 circuit. And those can be just perfectly fine. Logically, they're all the same. They just won't be as good at performance because now you're on a shared link and you're going across longer distance. So the best practice is to find a Fabric node which is very close, but if depending on your experiment, there's other ways we can do it, and it may be just fine for the objectives.
Great, thank you. Our next question is, with so many options for Fabric network services and slice topologies, what is the best way to design a slice which includes one or more facility port connections to external resources?
So this is one of the most probably interesting things about these facility ports, is that how they're going to be used is very, very much determined by what the objectives are of the experiment and the research on Fabric. So what we found is that we really need to have a design phase up front, and we are on the Fabric team, we're very open to helping with that because we have a lot of experience about different ways to connect things. So for someone who has experiment in mind on Fabric, some research topics, and they have an external resource they'd like to connect to via facility port, I encourage you to first think, what are the objectives, what are the key things, what are the other resources that you want to get connection to, what are the resources on Fabric? Is it important to just basic connectivity, or is it performance, or is it repeatability? And really do some design work about what you want to do experiment-wise. And I would encourage you to involve the Fabric team, because we can provide some insight about what the people have done, and also help think through all the things that are possible in Fabric. So it's really case by case, I guess, is the answer.
Great, thank you. Do you think there will be a lot of slices which include a heterogeneous set of external resources? Or is it typical for an experiment to focus on only one type of facility port or external resource?
Again, this is also kind of custom. I think if I look at what's now evolving on Fabric, with all these external resources being connected, and we're getting more and more interest, and we have probably 20 or so, maybe even more facility ports connected now. To me, the power, I think, is going to be in the heterogeneous resource. So people who are going to build experiments and do research on Fabric, was connect in a bunch of different resources. So maybe they connect in Chameleon resources to Cloud Lab resources with the National Research Platform resources, or maybe they want to include wireless test beds like Cosmos or Powder into some of the infrastructure type of test beds. So I think the power is going to be longer term to connect heterogeneous resources, and there's more interest now in HPC facilities. So I think that's going to be the power in the future. Right now, most people are focused kind of on one specific resource, where maybe they're using Cloud Lab or they use Chameleon. They're kind of more focused on just integrating the resources across the other external resources they're most familiar with. But I think longer term, I think it'll be a heterogeneous set of resources where there'll be a lot of value add.
Great, thank you. What are the best approaches to use facility ports to build experiments which take some specific production data flows and run them across Fabric as part of an evaluation or comparison of a new in-network processing or data movement process?
Yeah, this is an interesting area. So we are seeing several researchers and groups on Fabric now who they want to figure out new ways to integrate network services and insight services into their production workflow. So the LHC community is one where we see work from both the CMS experiment and the Atlas experiment. So from both those cases, we have worked with those communities to build paths across Fabric where they can take production data flow. So for Atlas, for instance, the University of Chicago, they move data from University of Chicago to CERN, or basically the other way, from CERN to University of Chicago, across the production infrastructure. But we designed a path on Fabric and a connectivity on Fabric to where we can peel off certain flows from their insight analysis resources, and they don't have to make any changes on the insight, but they can take certain production flows and move them across Fabric in a temporary way. And then they build services on Fabric to do in-network and computation and analysis. So there's a lot of good ways where you can really integrate Fabric networking, Fabric paths with production resources and really get a good comparison. Like, here's what happens in today's workflow. Here's what happens when we run the data across Fabric through this in-network computation model. So there's a lot of ways to do that. And it does take some design work because you try to do it in a way that minimizes impact to the existing insight resources.
Great, thank you. And we have one more question. What is the best way to make an experiment repeatable on Fabric using facility ports and external resources?
Yeah, again, so I think repeatable, it depends if you're trying to do things repeatable at the network layer or just the computation layer. You can design it differently, but if you want to do both, I think the layer 2 point-to-point service that I mentioned earlier in the presentation, that provides you an opportunity to build slices on Fabric, which include computation resources and storage resources, and tie them together with network resources. And with the layer 2 point-to-point, you can control the quality of service, you can control the path, and you can vary it if you want to get longer paths and shorter paths and compare it. So I would say the ability to reserve resources on Fabric to get the same set of resources at the same sites and then glue them together with a deterministic network service like the layer 2 point-to-point provides a really nice way to do things in a repeatable manner.
Thank you so much. And thank you both, Tom and Ben, our speakers for today. And in addition to our presenters, we also want to acknowledge the behind the scenes team listed here who worked diligently to bring this webinar to production. And also thank you to the audience for your participation in today's webinar. In addition to us recording this webinar, we will also email everyone who has registered a list of resources. So keep your eye out for that. The slide deck will be shared along with a link to our Slack channel and our Connect with Us form. We hope that you will reach out to the Fabric team for any questions or if you need any support. Our webinars next month are Mastering Fabric Tips and Tricks webinar series on December 16th at 3 p.m. Eastern. And then we have Stitching Together Innovation with Fabric Users on December 17th at 2 p.m. Eastern. And the Tips and Tricks webinar is focused on existing users, while the Stitching Together Innovations webinar will be focused towards new users. And we would appreciate it if you could forward any of this information to the relevant users in your community. As a final reminder, please submit your Fabric matrix and make sure that your project abstract in the portal is up to date, because we use that information for our outreach, including our website. So thank you all again, and I hope you have a wonderful day.